Hi students, welcome to Easy Chemistry by Pathan, and today we are going to discuss numericals on Kolrausch law. Very important and easy numericals in electrochemistry. And here we have a problem. Calculate Km naught means molar conductance at infinite dilution for calcium chloride and magnesium sulfate using the data given below. Lambda naught calcium 1 naught, that is 119 Simon centimeter square per mole. Lambda naught for chloride 76.3 Simon centimeter square per mole. So lambda naught for magnesium given, lambda naught for sulfate given. So conductance, molar conductance at infinite dilution of all ions given, they are asking for calcium chloride and magnesium sulfate. Let me discuss about this. First we have to write the given data. Lambda naught value given, this all clearly. So directly I am going to calculate Cap. Km naught calcium chloride equal to lambda naught calcium 2 plus lambda naught chloride minus, in calcium chloride 2 chlorines are there, that's why 2 we have to write. Then you go for that here. Calcium 2 plus ion concentration 119 plus chloride how much given? 76.3. so you have to multiply with 2 into 76.3, that is equal to how much you are getting? 271.6 Simon centimeter square per mole. That is the first problem. Problem number 2. In this only. Cap naught M magnesium sulfate equal to lambda naught magnesium 2 plus lambda naught sulfate 2 minus. Values given: magnesium 2 plus 106 plus sulfate 160 106 and 160, that is equal to 266 Simon centimeter square mole inverse. So like this we can calculate easily. So molar conduction of ions given and molar conduction of compound we have to calculate, and this is the method to calculate molar conductance of given compounds. Clear? Easy. Go for another problem. Here we have problem number 2, and this is previously given. The molar conductivity of 0.025 mole per liter methanoic acid, that is formic acid, is 46.1 Simon centimeter square per mole. Calculate degree of dissociation and dissociation constant. So molar conductivity they only given. We have to calculate degree of dissociation and dissociation constant. 2 problems are there here. 2 problems. Clear? So we have to go for that. How to calculate degree of dissociation and dissociation constant. Clear? First, what they given? Molar conductivity. Molar conductivity. How much they given molar conductivity? 0.025. So molar conductivity equal to 0.025 mole per liter. Clear? Molar conductivity. This much they only given. And methanoic acid is 46.1. 46.1. Clear? 46.1. And another given that lambda not H plus value, lambda not HCOOH format ion value given. So I am writing here lambda H plus equal to 349.6, lambda naught format ion equal to 54.6. These values they given. From this we have to calculate degree of dissociation and dissociation constant. Let me go. First we have to write the equation for dissociation of formic acid. Formic acid dissociation or methanoic acid we can say H plus COOH minus HCOO minus. We can write HCOO minus. This is ionic equation for formic acid. Clear? Now we know that lambda or capium of HCOOH equal to lambda naught H plus lambda naught HCOO minus. Substitute the values given 349.6 plus 54.6. Nothing but how much you are getting? 404.2 Simon centimeter square mole inverse. So what we calculated? Molar conductance at infinite dilution of formic acid we calculated. But they asked degree of dissociation. So degree of dissociation we need molar conductance at infinite dilution. So let me go that. Degree of dissociation. How to calculate degree of dissociation? And so one part is completed. We calculated molar conductance. Now degree of dissociation. Degree of dissociation alpha we know very well. Lambda m HCOOH upon, that is cap m also we can say. Lambda or cap. And cap m not HCOOH. And they given cap m, that is 46.1. and we calculated infinite dilution, that is 404.2, that is equal to 0.114. So we got degree of dissociation. Degree of dissociation. Clear? Next, you know equation already. HCOOH reversible gives rise to HCOO minus plus H plus. And initially concentration is C. And initial concentration of products are always 0. After T time, change in the concentration C minus C alpha. Here also C alpha and here also C alpha. This you learn in your first PUC. Now we have to calculate K value, dissociation constant. HCOO minus concentration and H plus concentration means product concentration upon reactant concentration. Reactant concentration. That is equal to substitute HCOO minus how much? C alpha. C alpha into H plus. H plus how much? C alpha into C alpha. Clear? C alpha square you are getting. Here. C alpha square upon C alpha square. Sorry, C alpha. C alpha by C minus C alpha. C minus C alpha. This is C minus C alpha. That implies C alpha square upon 1 minus alpha. This is 1 minus alpha. That is equal to, if you substitute the values, 0.025 into alpha square. Alpha value how much we got? C value they given already initially. C value they only given. Here they given the C value. Concentration. How much given? 0.025. 0.25. In the problem they given. So that value alpha square 0.114 whole square upon 1 minus alpha 0.114. That is equal to, if you go on through simplification, 3.249 into 10 raised to minus 4 upon 0.886 you are getting. Nothing but 3.667 into 10 to the power of minus 4, and this is K value. They asked a degree of dissociation and dissociation. Degree of dissociation K value here we calculated already, that is alpha value 0.114 we got. So like this, degree of dissociation and dissociation constant both we can calculate. Clear? And this is problem number 2. Next we have another problem, that is problem number 3. Look here, another problem they given here. The equivalent conductance of NaCl, HCl and sodium acetate at infinite dilution are 126.45, 4, 26.16, 91 ohm meter inverse, centimeter square equivalent inverse at 25 degrees Celsius. Calculate the molar equivalent, that is cap EQ of acetic acid at infinite dilution. Look here, The values what they given I am writing. Cap M naught HCl given 426.16 Simon centimeter square mole inverse, and cap M NaCl is given 126.45 centimeter square mole inverse, and cap M acetic acid is given CH3COOH. Acetic acid is given how much? 91.0 Simon centimeter square mole inverse. They are asking acetic acid equivalent conduction according to Kolrausch law. According to Kolrausch law, cap infinite dilution CH3COONA sodium acetate. Sodium acetate. Here this is sodium acetate, not acetic acid. Equal to lambda CH3COO minus plus lambda Na plus. This is they given 91.0. And similarly, cap infinite HCl equal to lambda H plus plus lambda Cl minus. Cl minus. How much given? 426.16. And NaCl. Lambda NaCl equal to lambda naught Na plus plus lambda naught Cl minus. How much given? 126.45. And these three are three equations. This you take equation 1 and equation 2 and equation 3. Clear? And from these three equations we can solve the problem easily. And now you go for by adding 1 plus 2 and making 3 means equation 1 plus equation 2 minus equation 3. What is equation 1? Lambda CH3COO minus plus lambda Na plus. Na plus. Clear? Plus second equation lambda H plus plus lambda Cl minus minus third equation lambda Na plus minus lambda Cl minus. First equation for sodium acetate, second equation for HCl, third equation for sodium chloride. Now substitute the values. 91.0 plus 426.16 minus 126.45. That implies lambda CH3COO minus plus lambda H plus equal to cap CH3COOH. Am I right? That is equal to 390.7 ohm meter inverse centimeter square equivalent inverse. Means here plus Cl minus plus Cl minus minus Cl minus will get cancelled. And minus Na plus plus Na plus get cancelled. Remaining what we have? CH3COO minus and H plus. By adding this you are getting 390.7 ohm meter inverse centimeter square equivalent inverse. And this is the method to calculate equivalent conductance of acetic acid. And this is one problem we have. Next, problem number 4. Another model we have here. Very important. The conductivity of 0.001028 molar acetic acid is 4.95 into 10 to the power of minus 5 Simon centimeter inverse. Calculate dissociation constant K for this condition. And lambda m is given, that is cap m is given for acetic acid 390.5. 390.5. Clear? Let me go for that. What they given, what we have to calculate. So concentration is given. Concentration how much? 0.001028 m. And cap m for acetic acid given 390.5. This is for acetic acid. And this is given data. From this we have to calculate dissociation constant. Dissociation constant we need means we have to calculate first cap m. Cap m. So cap m equal to kappa into 1000 upon molarity. Upon molarity. And cap m value they only given here. Cap m value they only given. And concentration given and cap m also given. From this we can calculate K value. K value. Clear? And cap m also we can calculate. So substitute the values. 4.95 into 10 to the power of minus 5 K value into 1000 upon molarity concentration how much given? 0.001028 to 8. Clear? And if you simplify this, you are getting 48.15 ohm meter inverse centimeter square mole inverse. This is cap m, molar conductance. But they asked degree, that is dissociation constant K. So to calculate K value we need alpha value. So we have to calculate degree of dissociation. Degree of dissociation. Degree of dissociation, alpha value we have to calculate. Alpha equal to cap m at given concentration upon cap m at infinite concentration. That is equal to, we calculated this is here at given concentration. At given concentration 48.15 upon, and this value is given 390.5. That is equal to, if you simplify this, 0.1233 you are getting alpha value. So degree of dissociation we got. From this dissociation constant we can calculate. Means dissociation constant K. So for that we need the dissociation reaction. So what they given? Acetic acid CH3COOH giving rise to CH3COO minus plus H plus and initial concentration C, and this is 0 and this is 0. After T time C alpha concentration is changed alpha, and this is also C alpha, this is also C alpha, and this is also C alpha. After some time, this is initially. From this we can go for that now. Dissociation constant K equal to product concentration upon reactant concentration. In previous problem also we did. That is equal to CH3COO minus how much? C alpha. So C alpha into H plus how much? C alpha upon CH3COOH how much? C minus C alpha. That equal to C, here C alpha square, C alpha into C alpha. How much you are getting? C alpha square upon, this is C, if you are taking simplification you are getting that 1 minus alpha. Means if you simplify this you are getting C alpha square by 1 minus alpha. Substitute the problem values 0.001028 into alpha value. Alpha value we calculated 0.1233 whole square upon 1 minus alpha value 0.1233. If you simplify this, K you are getting 1.78 into 10 raised to minus 5, and this is how to calculate dissociation constant. Means if you want to calculate dissociation constant, first you have to calculate degree of dissociation. Remember, whenever they ask dissociation constant, you have to calculate degree of dissociation. Degree of dissociation you need means concentration, that is the conductance at a given concentration and conductance at infinite concentration, infinite dilution, that both you need. From that we calculated alpha value. Means whenever they ask dissociation constant, you have to calculate degree of dissociation. Like this you can easily solve the problems from Kolrausch law problems. So based on this you solve few, then easy to you. Clear? So if you like this concept, please do subscribe my channel, suggest to your friends, and be safe at home. Thank you.